Hey, Algebra 2, do I have something fun for you today? We're on Quad 3, which is solving quadratic functions by factoring. We're going to kind of take this thing and run with it. The first thing we need to talk about is kind of just a reminder of what we are doing here. What does it mean to solve a quadratic? What we're trying to do is we've got this X and Y axis here. This is my X axis. This is my Y axis. When we say solve quadratics, we're trying to figure out if it touches, what I mean by it, the quadratic function, does that quadratic function touch the x-axis, and where does it touch? Okay, so when we solved using square roots, we were trying to figure out, again, where does it touch, if it touches, that kind of thing. And we're gonna do the same thing with another method today. This method is called factoring. You may have heard of it, you may not have heard of it. That's okay. We're gonna start right here, see what we can do. So what we're trying to do is some basic factoring techniques. The first thing we need to look at is how to take out the greatest common factor. So what we're trying to do is take out the largest number or coefficient and variable combination from each term. What do I mean by that? Well, here's what I mean by that. A says 3x plus 9. What can both 3x and 9 be divided by? What's the biggest thing that can both be divided by? We're going to essentially undistribute. We know how to distribute through parentheses. We're going to undistribute. We know that 3x and 9, that's negative 9, or no, that's positive 9, can both be divided by 3. So let's see, instead of dividing, let's do this. I'm going to set up these parentheses. Think of it as taking the 3 out in division. 3 times what gives us 3x? Well, that's just x. 3 times what gives us 9, and that'd be positive 3. Think about it like this. This is undistributing, because if I was to redistribute through, 3 times x is 3x, and 3 times 3 is 9. Okay. Now, it doesn't just happen with just coefficients. It could also be a variable. Look at number 2. I've got 15x plus 25x squared. Well, look at the coefficients. What's the greatest common factor between 15 and 25? And hopefully you said 5. I completely agree. I'm going to create some parentheses in here. And look at x and x squared. What's the greatest common factor between x and x squared? Well, they both have at least one x in common. I can bring an x out front. Because think of this as, again, undistributing, right? 5x times what gives us 15x? 3. 5x times what gives us 25x squared? Well, we know 5 times 5 gives us our 25, and x times x gives us our x squared. All right. What I want you guys, actually, you know what? I'm going to do one more. I'm going to do C. Then I want you guys to try D and E. Okay. Looking at C, I've got x to the 4th, or x to the 4th minus 7x squared. Now look at the coefficients. It's 1 and 7. We're not going to pull anything from 1 and 7. But x to the 4th and x squared both have something in common, and that something in common is x squared. Think about it like this: x squared times x squared minus 7. Because if I was to distribute this back through, x squared times x squared, that's that x to the 4th. And x squared times negative 7, that's that negative 7x squared. All right, with that said, give it a shot. Try D and E on your own and see what you come up with. Now that you tried D and E on your own, let's go ahead and take a look. I've got 9x cubed plus 18x squared. Again, think about the coefficients first, 9 and 18. What do they both have in common? What's the greatest common factor between 9 and 18? I hope you said 9. And then I've got to look at x cubed and x squared. What do they both have? What's the greatest common factor between x cubed and x squared? That'd be x squared. So I can pull out 9x squared from both of these. What am I left with? Well, let's try to rewrite this here. Well, 9x squared times what gives us 9x cubed, right? Well, we know 9 times 9 was our 1, and x cubed divided by x squared just leaves us with an x. And think about it, 9x squared times x would be 9x cubed. Well, how do we get 9 times what gives us 18? Well, that would be a 2. And then x squared, x squared times 1. So this is like x squared plus 2 times 1 are just 2. This is the best we can do right now with that. And again, check your work by distributing. 9x squared times x is 9x cubed. 9x squared times 2 is our 18x squared, right? Like I said, I like to call it undistributing, right? We're pulling the greatest common factor out. In E, 2x cubed minus 4x squared plus 8. Now, I'm going to make a little quick notification, not a notification, but something I'm just going to look at this thing right here. And I'm looking to see something I notice here is I have at x cubed and x squared, but I don't have an x value on the last term. I cannot pull something with an x out. They don't all have it in common. All three of those terms don't have that in common. But let's see what we do have in common. 2, -4, and 8. I see that one. We can take 2 out of all of these. 2 times x cubed minus 2x squared plus 4. And if you don't believe me, distribute back through. 2 times x cubed is 2x cubed. 2 times -2x squared is -4x squared. And 2 times 4 is 8. Now you're going to say, Mr. Brayman, why do we do all that? Well, it's not going to be evident quite yet. It's not going to be evident quite yet. But we're going to do one more thing, and then it will start to be more evident as we move through. It'll start to be more evident. So what we have is our first, what we're calling factoring pattern. Okay, we're calling this our factoring pattern. And what we're going to do is this. It's called the difference of squares. This applies to quadratics that contain perfect squares. They follow a factorable pattern of a plus b times a minus b. What does that mean, Mr. Brayman? And I'm glad you asked. The first step in all of these things is always checking to see if they have the greatest common factor. Well, with x squared and -64, there's no greatest common factor. But x squared and 64 are both perfect squares. Here's what happens, right? Take the square root of each thing individually. Ignore the negative sign for a second. What we'll end up here is x plus 8 times x minus 8. And if you're not sure if that works out, it does. Because remember, FOIL or distribution in this case, x times distribution, x times x minus 8 would be x squared minus 8x. 8 times x minus 8, 8x minus 64, so plus 8x minus 64. You will notice right here what happens. Negative 8x plus 8x disappears. You're left with 8x minus 64. You may have heard FOIL. I'm not going to use FOIL a whole lot because that only works for binomials. And we're going to eventually get past binomials. So we're going to talk about distribution more. Okay. X squared minus 144. Think of this, you could think of this like this. X squared minus 12 squared. So put those into the factoring pattern. This would be x plus 12 times x minus 12. Now, Mr. Brayman, what if it was x minus 12 times x plus 12? Does that still work? And to you, I would say, yes. Yes, it does still work because multiplication doesn't matter which order you do it. Well, what is 4 times 5? That's 20. What is 5 times 4? Well, that's still 20. The order doesn't matter. Okay. Ooh, here's one. 16x squared minus 81. What squared gives us 16x squared? How about 4x squared? Because 4 times 4 is 16, and x times x is x squared. Minus, well, 81, the square root of 81 is 9. So think about these things. The two things I've just put in there as the squares, those are what I'm putting in my a's and b's. 4x plus 9, 4x minus 9. Okay. And it also can be done. It also can be done with multiple variables. Well, what square gives 100? That would be 10. What square gives us x squared? X. So 10x squared minus 9y squared. Well, what square gives us 9? That would be 3. And what square gives us y squared? That would be y. So this is like 10 squared minus 3y squared. In other words, what I'm going to end up with is 10x minus 3y times 10x plus 3y. And again, you could put plus 3y, then minus 3y. It doesn't really matter. Remember, multiplication works both ways. Okay, that's what's called the difference of two squares. You need to have perfect squares. Check, please, 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 please. Check for a greatest common factor first. We didn't have it here. We'll talk about it later. Check for a greatest common factor, and then look at this. Do you have two squares with difference? Remember, difference means subtraction. Do you have two perfect squares that are being subtracted? Well, then you can do difference of squares. Okay, that's a very specific one. Let's go to a more general one, okay? This is called product or sum factoring. I'm sorry, product sum factoring, not or, product sum factoring. This works on trinomials where a equals 1. And you're going, what is a? What is he talking about? Remember, we're working with ax squared plus bx plus c. That's what we're working with, okay? We're working with it when it's a is just 1, when it's just x squared, okay? When it's just x squared. And here's how we do this one. Notice how this is just x squared. It says find the two terms which multiply to the third term and add to the second term. In other words, what multiplies to 15 but adds to 8? What multiplies to 15? What multiplies to 15 multiplies to 15 but adds to 8? Well, multiplies to 15 and adds to 8. So this is one of those cases where you're going to need to know your multiplication tables pretty well. And knowing my multiplication tables pretty well, I can go through it, right? 1 and 15, 2 doesn't go in, 3 and 5. Wait, 3 and 5? Well, 3 and 5 multiply to 15 and add to 8. That's what happens here. We end up with x plus 3 times x plus 5. And if you distribute that back through, it will end up being x squared plus 8x plus 15. Let's do one more example, and I'll have you try a couple on your own here. B says x squared minus 11x, oh, there's something interesting, plus 30, plus 30. So we need what multiplies to 30, positive 30, but adds to negative 11. That's really interesting. Well, let's kind of reason some stuff out here. If we're adding to a negative number, but multiplying to a positive number, we're adding two numbers together that end up being negative, but when we multiply them, they're positive. What could we tell? What could we say about those? You know, they would both have to be negative. The only way to add two numbers to get a negative number and multiply to get a positive is to have them both negative. But let's go ahead and check this out here. I know that 1 and 30 multiply to 30, but that adds to 31. I also know that negative 1 times negative 30 multiplies to positive 30, but that adds to negative 31. What else do we have in here? We got 2 and 15. Well, 2 and 15 don't add to negative 11. 3 and 10, that's not going to work. 4 doesn't, but how about 5 and 6? Or in this case, negative 5 and negative 6. So negative 5 and negative 6. That adds to negative 11. Does that multiply to positive 30? Sure does. In other words, what you're going to write down is x minus 5 times x minus 6. This is your factored form. This is factored form. Okay. Now here's what I want you guys to do. I know it's a lot. It's okay. It's okay. Maybe the first time you've ever seen this, and that's okay. Remember what we're trying to do. What multiplies to the third number, to the end value, in this case, negative 9, what adds to negative 8. On D, what multiplies to negative 18, but adds to positive 3. So what I want you guys to try real quick is C and D. Go ahead, hit pause, give it a shot. All right, now that we are back, we have things. Well, this case is a little different. What multiplies to a negative number but adds to a negative number? Well, that means one of each. We got to have one of each in this case. What I mean by one of each is one has to be positive and one has to be negative. And so what happens here? Well, what multiplies to -9 but adds to -8? What multiplies to -9 adds to -8? Well, this is kind of an interesting one because I know that, how about -9 times +1? -9 times +1. Yeah, that works because that multiplies to -9 and adds to -8. So what we would write here is x minus 9 times x plus 1. And you can check it. You can distribute it if you want. Okay, let's see here. We got one more that you practice with. What did you find that multiplied? What did you find that multiplied to -18 but adds to +3? If you're multiplying to a negative number but adding to a positive, well, when you're multiplying two numbers together and it's negative, one of them's got to be negative. Not both, but one of them has to be. And let's see here. How about, let's see, 2 and 9's not going to work, but how about 6 and 3? If I do +6 and -3, that adds to +3 and multiplies to -18. What we would have here is x plus 6 times x minus 3. All right, that's product and sum factoring. That's product and sum factoring. Okay. Now, what we're going to do, hit a little pause right here. We're going to turn this into part 2. Now, you probably watch both parts on the same day, but I want to give you a little bit of a break here. All right. What we're going to do is move on to what happens when A isn't exactly 1. When A is not 1, we have another really cool method to use. So that's the end of part 1. Go ahead, just kind of clear your mind for a second, and then in a second, you'll start part 2. Okay, see you in a minute.